Hey guys, what's up everyone? Welcome back to another video from the AP3X Institute of Mathematics, where we assist students primarily in the cohort of CSEC, CCSLC, SEA, ED, Excel exams, City and Guilds, CAPE, and college math courses. Alright, now in today's video, which is a part 2 to our previous upload, I will of course leave a link down in the description and right here in the cards for you, where you can get access to watching the previous video that we spoke about factoring quadratics. Of course, you're definitely going to want to tune into that video before and then come to this one, because in this video we are just going to be applying the steps that was previously discussed in video number 1. Alright, of course this is the second video that I've been posting on this new channel, so of course if you are getting any sort of value and you are learning how to practice math and to become better, of course recommend the channel simply by clicking the share button and to your other friends who may be struggling, who maybe want to get better at math. Of course, leaving a like if you're getting any sort of value, and of course to be notified in the future, please smash the subscribe button below and turn on the post notification bell. Alright, now as mentioned, this is factoring quadratics and we're going to be looking at applying the steps, but we're going to be taking it easy with a few basic examples. All the steps were discussed in the last video. As you can see here, step 1 is to find the product of AC. Step 2 is to list all the possible pairs of factors of AC, of which listing them we're going to select a single pair that will find, or that will result in, the coefficient of the middle term, depending on if we may find your sum or your difference. Alright, of course step 4 is where we just take these factors, we substitute them for the middle term to expand the expression so as we can factor by grouping. Alright, so of course check that video out, definitely first in many to come. On our weekends we are going to be posting videos on Fridays and on Sundays, so look out for a new content each and every time. Alright, and now please share and let's get right into the video. Alright, so we've already gone through the prerequisites of what is required to effectively factor any sort of quadratic expression, regardless of the coefficients or the signs. So let's take it easy with a very simple example here, where the coefficient is 1 and the middle term coefficient here is 7 and the constant here is 12. We already looked at a few ways of how to approach it depending on your level, but of course at my level, being an instructor, I am able to actually factor this without even doing any sort of calculation. Of course, you want to get to that level, you're gonna have to have rock solid knowledge when it comes to factoring. So let's jump into it here. Alright, now what was recommended in the last video for a person who is trying for the first time is to obviously list out the values of A, B, and C. Alright, so A is equal to, in this case, 1, because the coefficient of the x that is understood here is a 1. Alright, now the coefficient here of the coefficient of x here, which is represented by the letter B, is 7, and C is equal to 12. Alright, now if you're wondering where did we get those A, B, and C from, of course you can see here that I have already listed that the general form of any quadratic expression is in fact ax squared plus bx plus c. Alright, so here I got the A, the B, and the C from. So let's get back over here. Next thing here that we're going to be doing is that we're going to be finding the product of A and C. So here I like to draw lines. So I'll just draw here. That's the coefficient of x squared multiplied by the constant here. That is 1 multiplied by 12 is going to give us 12. Now, of course, step 2 is where we're going to be listing the factors of the AC product. And that is going to be 1 multiplied by 12. We can have 6 multiplied by 2. We can have 3 multiplied by 4. Right, those are the 3 factors here. All right, now we are interested in attaining back the coefficient of the middle term, which is 7. So we're going to be selecting from one of these pairs which one could possibly add or subtract to produce the middle term and simultaneously producing the product of AC. So clearly, if I were to subtract 1 from 12 or I were to add 1 to 12, I would not get 7. So clearly this would not be a correct factor. Then in this case now, if I were to take 2 from 6 or add 6 to 2 or either vice versa, I still would not be able to actually get the value of 7. But if you notice carefully here, instantaneously you should see add 3 to plus 4, you're going to find that the answer is 7. And if you were to multiply it 3 times 4, then you're going to get 7. So we're going to be assigning a plus to the 3 and a plus to the 4. So we end up with plus 7. So 3 plus 4 is equal to 7. And 3 times 4 is equal to 12. Very good. So here we go. We're going to be substituting the factors that we have selected here, which is positive 3 and 4, and we're going to replace the middle term with those factors. So we're going to have x squared here plus, we can put either one first, 3x plus 4x plus 12. Later on I'll show you some examples. We are just making the decision as it relates to which one should put first will become crucial when the coefficients are a little bit larger. All right, so here we go. Let's just continue on this one. We're going to be opening the bracket here and going to be opening the bracket here. I tend to not like using brackets. I don't like associating it like that. What I like to do is that personally I like to just kind of draw a line on the first two and draw a line on the next two. I kind of mentally like it like that. You know, putting those brackets there could, you know, be very ambiguous. So we don't want to, you know, when the, you know, we just don't want to make certain fundamental mistakes. So for the first two term, you can see that the common factor here is going to be and x. So x is a factor of x squared and x is a factor of 3x. So we grab one of those x's, and of course if you see that x squared divided by x, that is x squared divided by the factor x, you're going to see that this x is one time and this into x squared according to law of indices number 2. X squared minus x to the 1 is equal to x to the 1. So that's equal to x. Not so complicated. Just simply remember that every time an x goes into an x squared, you're going to be remaining with a factor of x. X into 3x goes 3 times. You can see clearly that 3x divided by 3 cancel. Then you're going to realize, pardon me here, 3x divided by x, in fact. Give me a second here. Let's undo that. That's 3x divided by, let's see here guys, just a second. Got you. So 3x divided by x in this case guys is going to be equal to 3. So there we go. So plus common factor here is 4. You can clearly see that 4 can divide into 4x and 4 can divide into 12. So 4 into 4x goes x times and 4 into 12 goes 3 times. Now you're going to be seeing something, you're seeing something now that's going to be repetitive across all quadratic factoring, and it's where the bracket over here is always going to be equal to the bracket on the right. So since those two brackets are expected to be the same for the factoring to be completed, then clearly you're going to see that the common factors are x plus 3. So we're going to just take those across here, and you can see that x plus 3 divides into here, leaves us with x, and x plus 3 divides into this section over here, leaves us with plus 4, and that there is our factoring. Now I could have actually explained this a bit faster if I wanted to, but it was just more on the fact that someone here could be watching this video who oftentimes don't really understand why we do what we do. So this example is just to get everybody comfortable in the video, and if the explanation was clear, if you haven't, click that like button, do so right now for me. And of course, if you're getting value, let's jump into the next question. So here we go. We're going to be looking at another example. Simple example, but it is going to be crucial when it comes to the tougher one. So here we go. Again, we're going to be doing, let's use a different color here. Give it some contrast. Okay, so that's here and here. Okay, so that is 1 multiplied by, in this case now we're going to be doing negative 21. So the common factor here, or sorry, the common product or the product is actually negative 21. So 21 is one of those numbers that they do not really have a lot of factors or a lot of pairs of factors. So we're just going to simply see that it's just 1 times 21 and 7 multiplied by 3. All right, so there's not much of a decision to make here. Clearly, the only way that we could get negative 4 is between the 7 and the 3. But how do we actually know what sign to give? Now, there is actually a way that you can know what sign. There's so many ways that you can actually determine what the signs are supposed to be for the terms. But I'm just going to just show you the mental one, the one that you don't have to study any rules or tables. You're just going to be just looking at the fact that the larger value of the two terms that you have selected will always take the sign of the middle term. So we know that right away, because 7 is larger than 3 and 4 contains the negative, then this has to be negative 7, and then obviously to get 4 you would have to add 3. Very simple. As long as you know the largest value of the factor you've selected, then assign the middle term sign here with the larger number and you're good to go. And you'll figure out if you need to subtract or add something to it. Very simple. So here we go. It is going to be, let's get some contrast in here, guys. We're going to have x squared, and we're going to have minus 7x plus 3x minus 21. All right, and once again, like in the previous example, we draw a line here and we draw a line here. Okay, now if we grab, remember it's the same procedure as we had up here, so you know that there's a consistency. So grab an x here, and we're gonna have x into x squared goes x times, and x into minus 7x goes obviously minus 7 times. Grab here, we grab a 3, and then we say positive 3, or 3x divided by positive 3 gives us x. And remember, we said earlier that for the factoring to be completed, the bracket on the left has to be exactly equal to the bracket on the right. So we could just actually just know that this is, or that ought to be x minus 7. But to verify, 3, positive 3 at that, into negative 21 goes negative 7 times. Positive divides into negative gives a negative. Alright, so you see the repetition here. That's x minus 7. And simply once you get these out of the way visually, then you're going to find that the answer is just matching with x plus 3. Alright, so you can see that that example was a little bit more speedier than the previous one because we are off it. I'm going to do one more for you guys. One more for you. Here we go. We're going to have, again, x. Now, we have to, pardon me, that's not what we're supposed to do first. We're supposed to actually say a times c. So that's 1 again times negative 10. Now, notice here that the factors of 10 are not many, just like the factors of 21. So that's minus 10. Or I should say just 10 times 1. So 10 and 1 and 5 and 2. And you can clearly see that to get positive 3, it obviously has to be plus 5 and minus 2. 5 take away 3, 5 take away minus 5 take away 2, pardon me guys, is equal to 3. Alright, so not too bad at all. Let's factor in, or let's substitute the middle term for those factors. That's x squared plus 5x minus 2x minus 10, and that's going to give us the expanded expression. Like before, grab here and here, take out the common factor here. X into x squared goes x times, and x into 5x goes 5 times, minus 2 is a common factor. Minus 2 into minus 2x. The minus 2 cancels, leave us with x. Minus divides into minus gives a plus. 2 into 10 goes 5 times. But by now, after the third example, you should really see that pattern here. That answer is just x plus 5 and of course x minus 2. Alright, so there we have it. There we have it, guys. Now what I want you to do for me is that I want you to pause the video and just kind of check to make sure that you've dropped a like, you've already left a comment, and be sure that you've subscribed and you've turned on the bell. If you've done that, I want you to now pause the video and I want you to work this question out, and I want you to tell me in the comments if it is that your answer was x minus is this supposed to be minus 7? Let me see here. Yes, it can be. Now let me know if your answer was x minus 1 multiplied by x minus 6. If you notice that I actually got the answer without actually doing any form of working out, well, if you need me to show you the trick in factoring expressions like these, leave me a comment down below and I'll show you the shortcut. But let me know in the comments if you were able to successfully get the answer x minus 1 by x minus 6. Alright, now let's jump into phase 2, where the questions just have a little bit larger coefficient. And so with larger coefficients, we're going to have larger products, and with larger products, we're going to have more factors. Factors that could be a little bit confusing in terms of which one to choose. These questions will bring out a little bit more in terms of quadratic. Let's jump into it. So now what we have here, guys, is that same procedure. Nothing has changed, guys. Absolutely nothing. We're gonna have 8 multiplied by 3. That's gonna give us 24. You could write it down if you want to. And of course the factors here are going to be simply 1 multiplied by 2 multiplied by 12 multiplied by 8, and let me see here, 6 multiplied by 4. Now I'm not sure if this is going to be important, but a lot of you guys may not have very good timetable skills, and I've often told my students that I don't really know my timetable very well, but what I do know is that I know how to play around with numbers. I know how to play around with numbers. I know how to use my 12 times table and extend it to my 19 times table. I just, you know, there's so many tricks in math that you can do. It's just more mental than physical. And once you get the hang of it, you're going to find the factors. For example, here, let's say that we have a student that is not very good at the timetable and they struggle. More than likely, if a product has like 10 pairs of factors, then you're going to find that this student is only able to list 3 or 4. So we want to improve that skill. Here's what you can do. Once you list the one pair of factor that you may remember, then what I want you to do is that I want you to cut any one of the values into a half, and then I want you to double the next number, and you're going to find a pair. And you can do this repetitively with each until you cannot find any more. And by the time you've listed out all the factors, you're going to find that you're going to select the correct one most times. Alright, so here we go. If we cut 24 into a half, we get 12, and if we double 1, we get 2. If it is that you cut 12 into a half, you get 6, and if you double 2, you get 4. And of course, if you cut 6 into a half, you get 3, and if you double 4, you get 8. So notice how that one factor can be used to attain so many more factors without you knowing the use of your timetable. Alright, brilliant knowledge. If you love that little demonstration there, be sure that you've dropped a like by now. Alright, so here we go. Which one do we choose? But there's a problem. let's identify the problem. The problem is going to be more mental, and it has to do with your ability to add integers. All right, that's a very, very solid topic that a lot of students take for granted. It's the addition and subtraction of integers without the use of the calculator. So that is how I'm able to do this, and you're not seeing me really use a calculator. All right, so here we go. We know that if we were to perhaps say 12 take away 2, we would get 10. And we also know that if we were to say 6 plus 4, we would also get 10. So right away you can see that this factor and this factor is actually the one that is in question. Now both pairs are able to produce the middle term respectively with their signs, but which one will produce the constant, that is the product AC right here? Which one will be multiplied to give us positive 24? We know that here 12 multiplied by negative 2, that gives us negative 24, and we have 6 multiplied by 4 give us positive 24. So clearly you can see here that it is indeed 6 and 4 that produces both the middle term and the product AC. So that is our decision. So you've got to be careful with questions like these. They do come up, and sometimes it's just a little error here in terms of your decision. So now that we're here, we're going to be doing 8x squared plus 6x plus 4x plus 3. Now earlier I would have said to you that factoring can be made easy depending on your decision that you make to do something this way or that way. Now notice here that nothing is wrong, and as I mentioned before, you can put the 4 first, then the 6, or the 6 first, then the 4, as long as they have the correct signs. But what I didn't tell you is that sometimes, depending on where you put it, it might send a different interpretation of the factoring. For example, if you were to ask a random student, whether they're good or they're not good at math, what is the factor of 4 and 3? They would buffle a little bit. They would probably get the answer right, but they're going to take a longer time. For example, if I were to ask you what is the 8x squared and 6x, most of you guys would jump out and say 2, or some would say 2x, or obviously we know that it's 2x. Yes? But with here, you're buffering a little bit, and that is the reason why whenever you have a odd number and an even number like so, and you cannot visually see the factor, then a lot of persons don't know that the simple answer is that the factor is 1. Alright? Now, if you can remember that once this happens to you, the factor is always going to be 1, then by all means it doesn't matter where you put these. However though, if I were to just be a little bit smart, then it would make my factoring a bit easy. So sometimes what you do will actually make the thing work better. So if I were to put the 4x here and a 6x here, okay, then you'd find that you can visually see that the common factor between 8x squared and 4x is actually 4x. And you can also clearly see that a common factor between 6 and 3 is 3. And that is just, you don't have to really go outside of your way to, try to mess the question a bit harder than it's supposed to be. So now that we've done that, okay, let's just fix it up a little bit here. Okay, we're gonna do same here and here. Okay, common factor is gonna be 4x, and 4 goes into 8, or 8 divided by 4 is 2, and x squared divided by x is x. And that's gonna be 4x into 4x is like saying 10 into 10 one time, 5 into 5 one time, 8 into 8 one time, x into x one time. So 4x into 4x goes one time. The common factor here is going to be 3, and 3 divides into 6 2 lots and leave us with the x, and 3 divides into 3 one time. So we haven't really done anything different from the example that we were doing before. It's just that with bigger numbers, you can have a little bit of, uncertainty. So you want to make sure that you eliminate all those uncertainties. Okay, so common factor here is 2x plus 1, and the remaining factor here is 4x plus 3. All right, beautiful. So I hope that was clear. Let's go to the next question. Again, we're going to speed this up a little bit. That's 6 multiplied by negative 20. 6 multiplied by negative 20. That's going to give us negative 120. So, as I mentioned to you before, when the number gets big, then you got to be a little bit smart. Now, I'm going to expose you to another number manipulation technique. Earlier, I showed you about cutting this into half, doubling that number, cutting that into half, doubling that number. I'm going to show you a little trick here that I learned a decade ago from one of the best math teachers that I've seen with my own eyes. Alright? There are many great mathematicians, great math teachers, but he's just one of the great. I hope that he's watching this video. But here we go. We have here 6 multiplied by 20. Now, if we were to perhaps say break this 6 up into just a little bit smaller, and times 2, and if we were to break up 20 into say 4 times 5, then all we have to do, this is really smart, what we have to do is just swing a couple of arcs. So we're going to swing an arc, and then we're going to say 3 times 4 is 12, and 2 times 5 is 10. See, there you can see we've produced another pair by that. But whilst producing another pair, that pair simply cannot give us 7. So what we can do is that when we swing the arc like that and it doesn't suit us, we swing the arc another way. Let's do 3 times 5, 15, and 2 times 4, 8. Aha! 15 multiplied by 8 is 120 when we assign to either numbers, negative 120. But then notice here that if we were to subtract 8 from positive 15, we would get 7. Really nice. We didn't have to list out all the factors. We didn't have to say half of 20, 10, double 6, 12, half of 12, 6, double that. We didn't have to do that. You can see that we found the answer easily by just swinging a couple of arcs. Nice little trick there. Let's jump into it here. We're gonna have squared, and already I mentioned to you that sometimes where you place the factors will make the factoring simpler. So here, I think that if I were to put, let's say here, the 15 with the 20, I can see that the factor is, and if I put the 8 with the 6, I can see that it is 2. Again, it doesn't really matter where you put it, but just not to make any fundamental errors, be smart about where you're putting them. So I'm going to say 6x here, 6x squared take away 8x. I'm going to have plus 15x take away 20. And again, I do the same procedure as before. Common factor here is going to be 2x. 2 into 6 goes 3 times. X into x squared goes x times. 2 into 8, or in this case minus 8, goes minus 4 times. X divides into x, cancels, or it goes 1 time. Common factor here is going to be 5. And you can see that 5 into 15 goes 3 times, leaving the x, and positive into negative is a negative. 5 into 20, 4. So clearly our answer is going to be 3x take 4, and then we're going to have 2x plus 5. Absolutely brilliant. Okay, really good technique when it comes to actually factoring better. So here we go, guys, another one here. Right, I'm not going to leave you stranded. I'm not going to make an assumption that you know what you're doing. Let's just dig deeper. Here we go. 15 multiplied by minus 3. So that's minus 15 multiplied by, or I should say, pardon me guys, I just have a little bit of sound in my background here. I apologize. Positive 15 multiplied by minus 3. And that's going to give us minus 45. So once again, we can do the same procedure. We can use what we have we already have a factor of 15 multiplied by 3, then we can just say 5 multiplied by 3. We can break this down even further. 5 multiplied by 3, and then we can have 1 multiplied by 3. So we need back negative 4. So let's do 3 times 3, that gives us 9, and 5 times 1 gives us 5. So to get back minus 4, we know that the larger of the two factors that we have selected will take the sign of the middle term. And clearly the only way to get 4, or to get down or get up or get higher, as high as minus 4, we're going to have to add 5. So the answer is here, and it gives us the end term. So 15x squared, we're going to have, again, let's make a decision. Should I put the 9 beside the 15 and the 5 beside the 3? No, I would put the plus 5 here, x, so I can clearly see that there's a common factor of 5, and I would just say minus 9x, and clearly with the minus 3 you can see that a common factor is of course 3, or minus 3. The common factor here now over these two is 5, and x, and 5 into 15 goes 3 times, x into x squared goes x times, of course 5x into 5x, like previously, 4x into 4x goes 1 time. Common factor between minus 9 and minus 3 is minus 3. Okay, bring down the minus, grab a factor, minus 3, and then we're going to say minus 3 into minus 9 goes positive 3 times, leaving an x, and minus into minus goes positive, 3 into 3 goes 1 time. So our final result here is going to be 5x minus 3. Notice now that I am actually writing what is left before I write the common factor. Do I have to write the common factor first? No, you do not. Why don't we? Because multiplication is commutative across algebra. Now what I want you to do, again, like previously, pause the video and work this question. Work this question, guys. Now what I want you to do here is actually go, and I want you to say, is the answer 2x and x, and we're gonna have minus 3 and minus 2. Let me know if that was your answer, and leave it in the comments down below. Of course, leave me a like, leave me a comment, share this out, and do not forget to turn on the post notification bell. Alright, so this was a quite interesting video. Nothing of the sorts, nothing too challenging, just a little bit of tricks and normal manipulation. Alright, now I have one more. I'm gonna work one more example for you, but this time I'm just gonna highlight the fact that I don't want you to get scared. Oh my god, I said squared. Pardon me. I don't want you to get scared when a question that appears to be something that you know, but it doesn't look like what you're accustomed to, and then all of a sudden the whole process, you start to break down and forget those principles of what you're doing. Now remember that the general form of a quadratic expression, let's pull that up on the screen, it's going to be important that you remember this base knowledge here. The general form of a quadratic is actually ax squared plus bx plus c. Now it was not written in stone that it could not be bx plus c plus ax squared. It was not written in stone that it could say c plus ax squared plus bx. We didn't say that. We said the general form is ax squared plus bx plus c, but nothing will change if it is that we actually switch up the positions. It's going to be the same. Remember, addition is commutative. Alright? So as long as the correct variables has their correct signs, it's the same expression, just a little bit scrambled. Now let's get back to the actual question. I'm just gonna work one of these because these don't come up a lot on the CSEC. You know, it doesn't come up a lot, but you just want to be prepared. Be prepared for the unexpected question, because that is exactly what you guys are doing. You're practicing what is common, and when something that is uncommon pops up, then it scares you. So here we go. Final question for this video. I'm gonna work the easiest one and leave you with the tougher one. Yes, I know. Why am I doing that? I want to challenge you. let me know in the comments how it goes. So here we go. We have 4 multiplied by minus 5, because in this case we are actually finding CA instead of AC, but CA is equal to AC. Alright, so here we go. That's going to be 4 times minus 5. That's going to give us minus 20. And we're looking for 8. So let's do 10 times 2. That's the first thing that pops in my mind. If I find half of 10, I'll get 5. If I double 2, I'll get 4. Let's do again here. Let's do 5 times 4, 10 times 2. Let's do 20 times 1. Alright, so I'm looking for 8. So it's evident that if I were to take 2 away from 10, I could get 8. Very easily, you can see the factor. I listed the remaining factors, just, not per se that I am making it harder. Once you've listed your factor and you've identified that you can get the middle term, then listing the others will not gain you any extra marks. So you can just avoid doing that like I just did. Once I recognize that 10 minus 2 was a factor, I jump here and I say 4. Again, I would love to have the minus 2 beside the 4. So I'll have minus 2x here, and I'll put the plus 10 right beside the minus 5x squared. So clearly you can see that the common factor here is 2, and 2 into 4 goes 2 times, and 2 into minus 2 goes minus 1 with the x, which is minus x times. Common factor here is going to be negative, I should say positive 5x. Okay, x is here, and 5 into 10 goes 2 times, x cancel x, or x into x goes 1 time, and positive 5 into minus 5 goes minus 1 time, and x into x squared goes x times. So that is it here, that the answer is 2 minus x, and it's going to be 2 plus 5x. Alright, so I do hope that this tutorial was good enough for you. I'm not sure, let me see how long we've been running this. We are approaching 40 minutes. I do believe that this is a really good practice session. I do recommend that, though, even though you perhaps watch this video, what you want to do is that you kind of want to try to work the questions over by yourself, and then press play and watch the video to see what you have done. You just want to remove the knowledge I've just given you remove the memorization of what I've just done and try to do them by yourself. Alright, now if this video was really helpful towards your factoring in terms of quadratics, right, do leave a like, share this out in your math groups, and this is just my way of doing and factoring quadratics. Do take care until next time. My name is Akin, your math tutor from the AP3X Institute of Mathematics, where learning the language of the universe begins here. I'll see you in another tutorial. Bye-bye.